Hey Joey, long time. Uh, uh, yeah, just because the difficulty of this problem, I want to try to make this quick. I think it'd be better if I kind of had my face and my graph paper here. So you're looking for the integral of this guy right here, 9 minus 25x squared dx. Now this thing is actually, it's impossible to do without thinking of it geometrically. So what you got to do is you got to figure out like what is the shape, okay? And experience will kind of tell you that this is actually an ellipse, okay? Now, the reason why that is because normally any kind of integration methods, there's so many of them that this is actually going to be impossible without thinking about it. What is it doing geometrically? And so what we want to do is we want to break this guy down so that he is actually a geometric visualization, right? So what we do is we're going to separate it from the idea of it being an integral, and let's just look at its general shape. So we're going to set the equation to y, all right, and we're going to unwrap this guy. So when you unwrap him, what you'll do is pre-calculus. Now this is assuming that your pre-calculus is real tight, is that you're going to have to square both sides, okay? All right, so now what you've got, you probably are going to see that this is actually shaping to be an ellipse already. We move this negative 25x squared to the other side. So now he's positive. Okay. And then what we want to do for an ellipse is we want to divide this guy by 9 because we need to set it equal to 1. That's kind of like the general form of all these, of all ellipses, right? Okay. Now, if this 25 would have been a 1, this would have been a circle. Okay, and then the same idea is you're going to use the circle formula to integrate because algebraically I can't even remember how to do that algebraically. So what I'm going to do is I'm going to continue to break this down, and this is 25 over 9. Now what I want to do though is I want to set this up so it looks like this. You remember you've got the general form of an ellipse like that, okay? This is very easy to graph if you know A and B. But what I'm going to do is I'm going to reorganize this 25 over 9. Doesn't reduce at all. What it really is actually this. Okay, so if you remember, the reciprocal of the reciprocal is like 2 fractions. Okay, all right, so then this guy's here, and then we've got this guy here. All right, now I'm going fast only because I see that the clock is like, you need this by 4. All right, so now what we've got is if we extend this just a little bit more, we can see that this is actually 3 over 5 squared plus y squared over 3 squared. Okay, now I'm putting them in parentheses because what that allows us to do is actually graph this guy. Okay, so if I go up 3, 1, 2, 3, I specifically use graph paper so I didn't have to be so grabby here, but you're up 3, and now since the center didn't shift at all, okay, there's no h and a k if that rings a bell, you're going to be at negative 3/5, and you're going to be at positive 3/5 over here. So what you're doing is you are finding the area of this guy right here, okay? Now typically you are finding, when you integrate, you're finding the area above the x-axis. So this is actually what we want. We want this area right there, okay? So this guy has to be looked at like this. Now what we also need is the formula for the area of an ellipse, and I'll get to that in a second. But as long as this makes sense, then that's the only way this guy makes sense. Okay, so this is basically finding the integral by geometry, rather than any of the integration by parts, substitution, trig, that partial different, like all those methods are not gonna be useful for you here, at least from what I remember. All right. So, anyways, what is the equation of the area of a general ellipse? Okay. Well, the equation of an area of an ellipse, yes, that is an ellipse. That is area equals pi times a times b, and all this is, that's the a, and then that's the b. Okay, and those can be switched. It doesn't matter because obviously multiplication is needed. So what we got is we have pi times a times b. So area equals pi times a times b, and you have everything. You know that it's pi times a, which we said was the height, which was 3, okay, and then b, which is 3/5. Okay, so now we have, when I multiply these fractions together, that's 9/5 times pi is just 9pi/5. But what we have done is we have found the area of the whole thing. Okay, here, when you do an integral, you normally don't do the area below the x-axis. So we got to cut that in half. All right. So if we cut that in half, okay, the area of the half of the ellipse, and I'll just write it like that, is going to be 9pi/5 divided by 2, which is multiplying by 1/2 will give you 9pi/10. All right. So that's pretty much, that is the answer to this. And so I just want you to know that if I don't know where you are in your study of integration, but this is really couldn't be done unless you did it geometrically. All right. As far as resources for some really good resources that I found are Wolfram Alpha. If you go to the website, what it does is it shows you lots of different answers and techniques, but if you hone in on the ones that make sense to you, it'll really kind of unwrap problems for you. So I recommend Wolfram Alpha. There are so many videos on YouTube. I would probably recommend is just going straight up to Khan Academy so that you can hunt it down by topic. They've got lots of Calc 1, Calc 2, Calc 3, they got it all. So I would recommend going there because they do it in a very systematic order. And there's and those are the free ones. Okay. So Wolfram Alpha, I'll spell it for you. Wolfram Alpha. And Khan Academy. Khan Academy, there's a lot of high school topics, but they go real high in mathematics as well. So Wolfram Alpha and Khan, those are the free ones. Oh man, there's a lot out there. How do you kind of weave through it all? Other than just, going to YouTube and Googling specific topics, if you want to get specific problems, I like the order of this. So if you need to study for a topic, I would actually go to Khan Academy and work through all of the problems and take notes from them. Honestly, that's what I would do. Wolfram Alpha is going to give you many different ways to solve a problem, and it'll give you a list. Some of them will be very advanced, but some will make sense. That's the one you want to. So if you get real stuck on a problem, I would go to Wolfram Alpha because their engine is outstanding. It's incredible. All right, but I know you're in a time pinch, and I'd love to talk to you later. So I'm going to let you study for your final, and when you're done, let's catch up. All right, talk to you later. Bye-bye.